There are so many different ways to solve a rational equation, like the one that is given to us on number 14. Remember, a rational equation has variables in the denominators, might have in the numerators as well. So take a look at number 14. It is pretty intimidating. When you look at it, like probably a little scared. I get it. It is. The rational equations are never fun to deal with. But first thing first, we're going to look at step by step, just like we did it in class. We look at all terms, they're fractionals, so that's great. One thing that I worry about is, do they all have common denominators? They don't. So what do? I'm going to start by factoring each of the denominators. And then I'm going to use multiplication to create common denominators. Okay, so the common denominator, no. I'm going to go in one by one. I'm going to try to factor those denominators. I'm going to start with the first one. The first one is x minus 4, linear. I cannot factor, no GCF, so I'm just going to write it as 2 over x minus 4. Just going to put it inside parentheses to kind of tell my brain that I did try to factor that one. Minus, the next denominator is x plus 1. I cannot factor that one either, so I'm just going to write it as it is, x plus 1, equals, the next one is a quadratic expression. So I'm going to do some side work on the side. We got x squared minus 3x minus 4. Can I factor this? Yes. I am going to try to use the AC method. A is equals 1, B is equals -3, and C is equals to -4. So we're looking for two numbers that multiply to AC, which is 1 times -4, -4, but add up to -3. Well, those two numbers are -4, +1. Therefore, because A is equals to 1, I can go ahead and say I found my factors. One of them is x minus 4, and the other one is x plus 1. All right, now we are ready to analyze this and find a common denominator. All right, looks like the very first expression, rational term, has x minus 4 in the denominator. The second one has x minus 1. And if you look at the third, the term on the other side, it has both of them. It does have an x minus 4 and it does have an x plus 1. Well, that's great. This is our common denominator. So we are now going to use multiplication to rewrite each of the terms with a denominator of x minus 4, x plus 1. Now, this process can be done many different ways. And there is no right or wrong. There is no better way. I'm just going to do it the same way I did it in class. We already have x minus 4 for the first term because now we need an x plus 1 to have all fractional terms with the common denominator. I am going to multiply the numerator and the denominator by x plus 1. Remember, whatever we multiply the denominator, we need to multiply the numerator. I'm going to do the same thing for the second. But if you notice, we do have x plus 1. Therefore, now I'm going to multiply the numerator and the denominator by x minus 4. Whatever we do on one denominator, we have to do it to the numerator to keep that fractional staying the same. The next one, on the other side of the equation, it has both. So I'm not going to change. It's already on a common denominator. All right. Now I'm going to rewrite one more time just to clean it up because it looks pretty messy. On the top, we got 2 that multiplies x plus 1 over x plus 1 times x minus 4 minus 5 that multiplies x minus 4 over x plus 1 times x minus 4 equals to 10 over x minus 4 times x plus 1. All right. Now, if you notice, the denominators are the same. Therefore, I'm going to create a new equation with only the numerators. I don't need the denominators anymore. So we got 2x plus 1 minus 5x minus 4. That is equals to 10. Still not a simple equation to solve, but compared to the first one, less intimidating at the top, right? Now I'm just going to solve this as I usually solve equations. Lucky us, this is a linear equation. So first I'm going to use distribution process to get rid of the parentheses. We get 2x plus 2 minus 5x plus 20 is equals to 10. I am going to combine like terms. I see 2x and negative 5x. That's negative 3x. I also see 2 and 20. That's going to give me 22 is equals to 10. Now let's subtract 22 on both sides to actually isolate the variable on one side. Negative 3x is equals to negative 12. Dividing by negative 3 will set the value of x to be x equals 4. So this is a possible solution. Why am I saying a possible solution? Because now we have to make sure that x equals 4 does not make the denominators of the original equation equals to 0. Remember, a rational expression, a fraction, is not defined if the denominator is equals to 0. That is x equals 4. All right, so now I'm going to rewrite my original equation, and I'm going to substitute in the denominators only this value for x. If that value makes our denominators, you only need one to be 0, not all of them, then it's not a solution. All right, so I'm going to start substituting. I'm going to substitute x minus 4 with 4 minus 4. Oh, wow, that comes out to be 0. But we cannot have a denominator that is equals to 0. Therefore, x equals 4 is not a solution. So what are the solutions to this equation? No solutions.